Hello everyone, I am Karthik from ITI section. My roll number is 20951230. Today on UI/UX, our topic is about interactive augmented reality authoring system using mobile device as input method. So let us see this tech talk topic briefly in further slides and know more about augmented reality and how augmented reality is different from virtual reality. Let us see uh, the brief information about the topic in further slides. So, abstract of our topic is the proposed system is a user-friendly interactive augmented reality authoring system, which is for users with basic knowledge of augmented reality or without programming skills. The user can wear the head-mounted display and easily create AR content by using sensors of mobile device. The users can also directly apply a variety of methods to interact with the AR content. Interaction with AR content is enabled by using the user hands, which is recognized by the camera attached to the HMD. The mobile devices senses sensor data. In order to evaluate the effectiveness of the proposed system, a system prototype was presented to users. A usability test was conducted with regard to AR content production and interactive tasks. So this is the abstract of our topic. The abstract mainly focuses on augmented reality and how the augmented reality is implemented in real life by using the mobile devices. Let us see the introduction of the topic in the further slides. Augmented reality technology allows the user to interact with a virtual object based on the real world. Through this technology, the virtual object is seamlessly presented to the user and provides a variety of additional information in various environments. Numerous studies have researched different types of AR technologies. AR Toolkit is a marker-based AR library that uses computer vision technology. It requires specific programming skills such as knowledge of C, C++. In general, AR applications are focused on arranging a virtual object in the real world and registration technology. AR Toolkit Plus, Dart, IATAR, Vuforia, etc. are examples of AR applications. Various types of AR content have been produced and used in mobile devices and desktop PC environments. In reality, however, it is difficult for non-computer experts to create AR content using AR programs. This has led to increased need for the development of AR content and applications that can be easily used by the common users. So this is the interactive AR authoring system and how AR works. So recently we have seen AR kind of thing that has been launched by Apple company, which is a replica of this AR. So it showcases how AR being developed by various companies through their technologies. So interactive AR authoring system. Basically, the system overview, if we look on it, we have a user, mobile and server. The user interface will be connected to the mobile sensors like haptic output, touch input, sensor input, marker input, gesture input, output. So these all are connected through their responsive sensors such as touch recognizer, handheld gesture marker detector, gesture recognizer, object render. So this all will combinedly form a command generator which will sends the server to generate the command which was asked by the user. The server will check through the database and marker ID base database and virtual object database, and it sends to the user and displays in the AR system. So in figure 2 briefly summarizes the proposed interactive AR authoring system. The system is divided into two cycles. First, if the user touches or makes a gesture using the mobile device sends the sensor data to the server. Then server creates AR or interface content, which is then shown to the user HMD. Through this, the user can easily create AR content. If the user operates the AR content, augments the 3D object of recognized marker. The server recognizes the user's interactive gesture and sends feedback data on the manipulated 3D object to the user and their mobile device. The mobile device provides audio and haptic feedback to the user using the feedback data. The system provides a tangible discrete control that enables the user to control the interface menu with a mobile device and gesture interaction. It also allows continuous interaction for the user to easily manipulate the 3D object. So interactive authoring interface. This is the interface that we have for an interactive AR authoring interface. So it mainly contains 3D object interaction, play, redo and create. So we have different kind of application features like tilt gesture and touch and scroll. The figure 3 shows the configuration of the interactive AR authoring systems interface. The control of the system is indicated on the HMD screen after the user touches the mobile device touch screen. The buttons on the right can be selected while scrolling uses the up and down tilt gesture. The system startup screen consists of 5 main buttons. The 3D object and the interaction buttons are used when the user is creating AR content. And the play button is used to preview the AR content that the user is working on. If the user selects the create button after finishing the AR content, the AR content is produced. So let us discuss what is this interactive features. The system integrates different methods of interactions such as gesture interactions with the mobile device. The mobile device interactions are tangible to the user, support discrete control. They also provide continuous interaction for manipulating 3D objects in combination with the interactions that use hand gestures. So figure 4 shows a user manipulating a 3D object. The user can expand or reduce the object by using a pinching gesture on 3D object integrated with the mobile device. Haptic or audio feedback regarding the AR content can also be provided. This is the figure 4 which showcases the AR. Design of experiments. The test compared an existing system with the proposed system in terms of perceived usefulness and perceived ease of use. The evaluation was rated on a Likert scale, with I being the most negative and the 7 being the most positive. 27 non-computer science major students studying design or education were recruited in order to perform the test. The participants ranged in age from 21 to 34, 21 are male and 6 are female. A demo video was shown to the participants of the proposed and existing system before the evaluation, and each individual was given 30 minutes to 1 hour of practice time. A scenario was explained to the participants and the task of producing AR content was carried out by them so that they could evaluate the usability of the systems. Table I list the simple basic tasks that the participants were asked to perform. So this is the table 1, which contains recognition markers, authoring. Select the 3D object that will reinforce onto the marker. Select the interaction that will be applied to the 3D objects, and interaction. Augment the 3D object for a marker. Rotate the 3D object. Transfer the 3D object. Zoom in, zoom out. So the results of the two systems were compared through the paid sample t-test. The proposed system generally received higher scores from the participants of the questions Q2 and Q3. So let us come to a conclusion that the proposed system provides an AR environment in which general users without any prior programming skills or knowledge of AR technology can easily create AR content, and shown that the test results unproposed with the AR content. The system provides an immersive AR environment to the user through HMD and has been developed to also provide simple interaction methods that are easily to understand.